of Electronics and Telecommunication Engineering Department, Walchand College, Solapur. My topic is MSP 430 microcontroller part 2. At the end of this session, student will be able to understand introduction to MSP 430, 28-pin devices TSSOP, 32-pin devices QFP, functional block diagram, MSP 430 G2X53, MSP 430 Central Processing Unit CPU, memory architecture, G series memory map. Content: explain MSP 430 28-pin devices TSSOP, 32-pin devices QFP, functional block diagram, MSP 430 G2X53, MSP 430 Central Processing Unit, memory architecture, G series memory map. Here, this one is MSP 430 microcontroller available in 28-pin devices TSSOP. So this is a 28-pin G series microcontroller. Pin number 1 VCC is there, and pin number 28 is a ground pin is there, and then most of these pins have multiple function. Each pin offers multiple functions. If you look at pin number 2, it can act as a port P pin bit number 0, and it can act as a clock for timer A. It can also act as an analog input, and it can also act as a comparator input. Because this particular MSP 430 microcontroller has one comparator, it has two pins X in and X out, would be used to connect an external crystal. Should choose to have that options. If we choose not to have crystal, then these two pins, pin number 27 and pin number 26, could act as a port pin, as we see here, port P2.6 and P2.7. It has three ports: port 1, port 2, port 3, and lot of functionality that is available in this microcontroller is distributed across the pin of these three ports. The MSP 430 lunchbox, it uses the bootloader method of programming this microcontroller. So they would use pin number 2 and pin number 3. Apart from that, across the chip we will see several functions here. So pin number 6, whenever external voltage that we apply, would serve as a reference voltage for the on-chip ADC. Here, this is the TQFP footprint of MSP 430 microcontroller. In this case, ADC 10 is available on MSP 430 G2X53 devices only. Here, if you see here, all the pins are around this IC. This one is a MSP 430 microcontroller functional block diagram. Here, there are two pins, X in and X out pins, to put an external crystal here, which would generate the system clock. It would also generate two more clocks called A clock and SM clock. A clock and SM clock are used by the peripheral which are available on the microcontroller, where M clock is used to power the CPU. It has RAM. There are two options. Either you get the 256 bytes of RAM, and we get the 512 bytes. It has ADC here, and you can get the 10-bit resolution ADC with the 8 channel. There are 3 ports are available, but depending upon the physical footprint, and may get the 1 port and 2 ports, or all the 3 ports are there. And each one of these port has a 8 pins are here. We have the USCI, that means Universal Serial Communication Interface. It has 2 parts to this USCI A0 and USCI B0. The USCI A0 offers 4 modes of operation. Either it can act as a UART, that means Universal Asynchronous Receiver Transmitter, or it can act as a LIN, that means Local Interface Network, or it can act as for infrared communication, or it can act as one of the SPI ports. We have another timer which also has a 3 compare registers. Both these timers are 16-bit timers. Watchdog timer, that means watchdog is a 15-bit watchdog, which means the maximum count that it will count before it overflows, and this would be used to reset the system is to raise to power 15, that means which is 32768. We also have a brownout protection, which means of the circuit will provide the brownout reset source. JTAG interface is there. This one JTAG interface, and this JTAG interface we could have access to the JTAG interface through the SPI by wire communications. We have seen all these interconnections of JTAG interface and SPI by wire in part 1. RISC architecture with 27 core instruction and 7 addressing modes. 16-bit address bus and 16-bit data bus. A set of 16-bit registers reduces fetches to memory. Maximum clock frequency is 16 MHz, that is the G series, and 25 MHz for the F series. Constant generator provides 6 most used immediate values and reduces code size. Direct memory to memory transfer without intermediate register holding. Word and byte addressing and instruction format. This one slides for MSP 430 microcontroller memory architecture. MSP 430 has a von Neumann memory architecture. In von Neumann architecture, there is only one of the set of addresses which over both volatile and non-volatile memories. Address bus is 16-bit wide, so 2 raised to 16 equal to 65,536. That means 64 kilobyte address. So address range is 0x000 to 0xFFF. MSP 430X has an address bus of 20 bits. So 2 raised to 20 equal to 10,48,576 addresses are possible. The memory data bus is a 16-bit wide and can transfer either a word of 16 bits or a byte of 8 bits. The address of a word is defined to be the address of the byte with the lower address, which must be even. Example, the 2 byte of the 0x4000 and 0x4001 can be fetched as a word with the address 0x4000 in a single cycle. Instructions are composed of word and therefore must lie at even address. So this one is a MSP 430 microcontroller series memory map. Here we have to concentrate only on last column, that means MSP 430 G2553. Here this MSP 430 G2553 having the memory size is a 16 KB, while input vector address having the range of 0xFFF to the 0xFFC0, while main code memory having the range of the 0xFFF to the 0xC000. Then information memory for the MSP 430 G2553 having the size of 256 byte and having the flash size of start 010FFH to the 01000H. RAM size is a 512K byte for the MSP 430 G2553 and it's starting the range from 003FF to 0x0200. While peripheral having the 16-bit size start the address 01FFH to the 0100H and 8-bit size having the 0FFH to the 010H and 8-bit SFR having the size 0FH to the 00H. So all these parameters are relevant to the MSP 430 G2553. Here this MSP 430 G2553 we are going to use in experiment board. That's why we have to concentrate on this last column only. This one is a memory map structure. Whatever right now we have discussed on this memory interrupt, main interrupt vector, main code memory or information memory, RAM, peripheral, all these are distributed in this address range. So this one is a memory map structure. references, we have to use datasheet of MSP 430 G2553, user guide MSP 430 G2553, launchpad development kit, that is the Texas instrument, user guide MSP 430 F2XX, MSP 430 G2XX family, that is the Texas instrument, and www.ti.com. Thank you.